So I just want to make sure you can see my full screen.
Yes.
Perfect. Sounds good. Yeah. So good afternoon, good morning, everyone, depending on the location where you are joining from. So yeah, so as Meeling introduced me, so she actually covered everything on the slide too. So I'm gonna start with the theme of the topic. The theme of the session for today is which is CUI, corrosion under insulation, and I believe you guys being affiliated with the Institute of Corrosion, you would be having a, I would say, some understanding about the CUI as a damage mechanism itself. But I'm gonna quickly share some stats about that and some brief introduction of this damage mechanism. So it's a type of degradation which is known to be happening under thermal insulation, and it's known to be caused by the moisture and aggravated by the chemistry of the environment where the corrosion is happening. So there was an ExxonMobil study that was published around 20 years ago that states around 40 to 60% of the piping failures in a typical oil refining facility are happening from CUI, and it was also declared as one of the expensive damage mechanisms among the expensive damage mechanisms in terms of management, whereas 10% of the overall maintenance spending was towards inspecting and managing CUI. So when we say about the CUI, so the very first thing that comes into our mind is that the moisture which is under the insulation. So the moisture comes from either infiltration, direct intrusion from rain, from snowfall, or it could be coming from the condensation. So so these are the two main mechanisms by which the moisture ends up having at the pipe insulation interface. So when we talk about the moisture, there is I'm going to talk about some in this presentation some field perspective of moisture infiltration. So obviously the word gateway is a very generic thing. So I'm going to give you some specific examples of what it means. How they really form in the field settings, how they end up how we end up having those in the real life things and in the real life situations. And now I'm going to talk about some CML ports, and then finally I would be sharing some solutions and the best practices that we have seen so far. So that would be more or less I would be covering in today's session over the next few minutes. So here are some examples of some different types of moisture gateways. So obviously starting from the left, we can see an elbow that having like a beaten up jacketing on a bend next to the flange. So obviously this could be attributed most likely, I would say it could be coming from the bad workmanship. Someone is not putting its all the things in place in a proper fashion. The one in the middle, you can see that two ends of the jacketing, they have they're wide open. So, and that happened due to the thermal expansion of the pipe. And I would say in this case that this could be the fault of specification, inadequate specification, where the proper overlap was not maintained, or the thermal expansion thing was not accounted for. So due to the thermal expansion, the jacketing, they ended up I would say parting its ways and ended up opening the insulation. And you can see all those torn up insulation that could be coming from some raven or crows or birds biting on those pieces of insulation. So all we could see some damage, and that's actually a moisture gateway. And the one on the right, it's like there is a rectangular box that is generally applied to over the grinnell clamps on the pipe shoes in the real life setting. So we can see that that thing has actually opened. So it could be someone stepping on that, and I know it's an easy access point. So we can see it's been opened. So that's because of the human interaction. So these are the three unique scenarios where all these can be termed in one, can be given a common name like as a moisture gateway. And the one in the middle, in the real life, we call that short lap. That's a technical term used among the tradesmen, among the trade persons. So another example of moisture gateway, this is one of the interesting one on the left. We can see there is the drain that is being connected to the pipe, and that drain was actually meant for some flushing, cleaning, or some drainage from the pipe itself. And so when they installed the drain and the insulation was installed, and they found that the swing radius of the drain is actually interfering with the jacketing. So all they could do, they end up trimming off the jacketing and insulation from that spot just to make sure they can operate the drain. And I think it's a nightmare for someone who is managing the CUI program, because in this case, so it's like like inviting the moisture from those locations. So that is something, what do we call, field retrofitting triggered errors, or it could be the result of the I would say improper dimensions between the what do we call, handle of the drain valve, or something, what do we call, swing radius is not accounted for, and the mismatch between swing radius and insulation thickness. So this could be, we can give it multiple names. So that's a typical example of field retrofitting that is causing some damage to the insulation. And the one on the right side is something, is an example of unsealed insulation termination. So you guys will be knowing about the guided wave ultrasonic thickness monitoring. So that requires some exposing of the pipes to allow that, placing of the guided wave hardwares on the surface of the pipe skin. So over there, but we can see some big problem over here. Like there is the seals or the end caps are missing in this case from the insulation. So these are also two examples, where we classify them as a moisture gateway. So these were typical examples. And then comes, Mother Nature. That kicks in. So here is an example on the left. It's, this guy, he loves to be walking on the to stay warm on the cozy pipelines. So especially in the winter. So if they're coming out of hibernation, they love to be going near to the pipelines. And the one on the right side are the falling trees that cause the damage to the jacketing. In both these scenarios, the jackets get crushed, and they cause, like the inducing the fish mouth openings in the jacketing, allowing the moisture infiltration. So these are some of the real life examples of how moisture gateways get triggered from the bad workmanship, from the nature driven events, from the field retrofits. We name that. So there are multiple reasons. So now another thing which is very common, like, in the real life, we see the CML points, or we call that TML ports. We call that, inspection ports. There are the different names, or, some people call that UT ports, ultrasonic thickness points, or things like that. So there are the different names, but the concept is same. So if we talk about the RBI document API 581, which is one of the leading document for risk-based inspection. So that mentions the reason why we have to have an inspection port. Obviously, to get the data which is of high confidence. And on the other side, it's really giving a warning that whenever we have an inspection port, make sure we should replace and reseal of the plug on those inspection port as soon as possible. So that is something, the part and parcel. So these two things should be read together. The first thing is giving you the high confidence, but second thing is a warning, because it can lead to the moisture infiltration. But if you look at the scenarios on the right side, we can see some of the duct tape or some warning tape is being placed on the inspection on these inspection points. And also we can see crimped metal panel on these inspection points. So these are the points where the moisture is gonna infiltrate and cause some accelerated corrosion on that. So two bad things will happen if these inspection ports are not managed and sealed properly. First thing, it's going to allowing the moisture to infiltrate, causing more corrosion, such as CUI. Plus, it's going to corrode the system more. So the data, which is supposed to be high confidence as per API 581, the expectation of API 581 is to have the high confidence data. So that's no longer going to be high confidence data because the moisture is causing the corrosion to exaggerate in certain portions. So the two bad things are happening for one same reason. So that's why there is a school of thoughts among the end users. They used to call that inspection port as a kiss of death. So because they had the problems in the past by having the inspection ports. And also here is some few interesting examples. So while API is clearly saying that we need to keep the inspection ports and plugs, we need to reseal them as soon as possible. It's imperative to do that. But in real life, what happens, like the plugs which are meant to seal those, the openings, they fall open by itself, because they are just like a friction fit into that cavity. They fall open and stay open for such a long time, like you will end up having the spiders staying into that place, or even the like the hornets or dirt dobblers, they end up making their dwellings in those portions, or even the rats can go through those openings. So that means those plugs stay open for long duration. So yeah, they call it dwelling. I don't think that's a bad thing if someone is doing the dwelling, but it's bad from the inspection people, because we are no longer having an useful data from these inspection points. So and another thing is the example of from the TML points. So sometimes these covers are even found missing. So this is an example of the pipeline where the cover is broken or it's been missing. And imagine that in the winter time, when there is a snow piles, and the snow is eventually going to melt, and then that will allow the moisture to infiltrate these points where the inspection ports cover is missing. So that's even going to be a nightmare. So these are the practical challenges with the CML points that actually discourage some owner user to stay away from the concept of CML, although CML is known to give the high confidence data. So, and another thing I just mentioned that that when moisture infiltrates, what it's actually doing, it's causing the exaggerated corrosion. So imagine that I'm just showing over here the cross section view of the pipe and the insulation and the portion where the inspection cover is missing. I would say, let's say I'm looking at the side view of this inspection port. So what's happening? The moisture, when it's infiltrating, it's causing more exaggerated corrosion at these portions. These portions where there is a crevice formation. So once the crevice forms, so it's going to cause localized corrosion in that portion, and maybe in this portion would be only just atmospheric corrosion. Whereas the inspection guy with the ultrasonic thickness probe would be mainly inspecting in that area where the bad zone is right over there, the one with the deepest pit. So basically, the gentleman who is doing the inspection over here is not capturing the worst spot, which is happening away from the scanning zone. So basically, in this case, we are having the data which is relatively giving you better thickness, but that's a false indication. So the data is no longer a high confidence data. So the whole point of explaining this one is that if the cover is missing, if the cover is not placed properly, it will eventually lead to some pitfalls in the data quality that is being collected from these inspection points. To address that, like the integrity products, we have some plugs that contain the metal skeleton, and that has an interlocking, like what do we call lips, so that even stay closed even in the event of the mechanical abuse, something falling on that. So that is something, the solution we have come across. So that's a practice becoming very popular in Canada, and even like in the United States. So because basically this practice of having the flexible skeleton, and having the ability to stay closed can help overcome many of the challenges which I shared in the previous slides. So another challenge that comes from the TML or CML points is the thermal loss from these locations, especially when you are going to have a CML point. You want to cut out the insulation, and that insulation we could imagine it's gone permanently. Why? Like because no one is going to take care for that in general. Like it could be placed there for, let's say, 1 or 2 inspections. Maybe if it's located at a point where the only ROP access guy can go and inspect that, there is no point, the ROP access guys generally don't have the deep pockets to really store the insulation. So what will happen in that scenario is the insulation will be found missing in those locations, and which actually, defeats the purpose, in somehow, because we don't want the thermal losses from from our thermally insulated systems. So to address that, there is another best practice that's been followed, and is the use of like I would say retractable pillows or something. So this sort of thing is screwed to the jacketing, so it serves as a, what do we call, permanent type of insulation that stays there, and that can be retracted. And especially with the ROP access guy, they can inspect, and they can stuff this thing back over there. So this is the way we can help comply with the concern which API 583 has mentioned, about the insulation removal evaluation. So that is something. And another thing, yes. So now coming to the some of the best practice, so generally, when API says that, oh, consider removing the insulation, where we can, we have the tolerance. So considering that thing, so many honor users sometimes, they end up, I would say, digesting that pill of thermal loss, just to avoid CUI issues. So here is an example, real life example. You can see the insulation terminations, and insulation is found missing on this pipe. Why? Because there are the protrusions, and these protrusions act as a point of moisture ingress into the system. So to avoid CUI, they just removed insulation entirely. So now CUI is avoided on this portion, but there is still thermal loss. So, and that thermal loss could lead to process inefficiency. To address that sort of situation, the best practice, that we have come across is to use of the pipe seal, like it's like a hardware that goes around this nodal protrusion and this portion, they go under the jacketing to give like a perfect sealing around this portion, and this portion can be insulated now without expecting any moisture infiltration. So this is how, this way we can avoid basically thermal losses and keep the CUI risk at bay. So that is something, the new practice we have come across. And speaking about other moisture gateways, so as I pointed out in the previous slides, like so of the portion where insulation terminates, that's the point of moisture infiltration. Grinnell clamps, the nozzles, and the flange openings, these are all the points of moisture ingress. So so we have like a different hardwares to address that. Like, so termination seal, it's like a flexible seal that goes around the pipe to keep this Pittsburgh end cap in place and giving a perfect seal. The clamp covers, which goes on the Grinnell clamps, to give a perfect seal. That I was showing an image where there was a rectangular box that was damaged because we love to step foot on that. So to avoid that sort of situation, the Grinnell clamps are now being, especially in the Canadian SAGD facilities, they are being covered by using these clamp covers. And then comes this pipe seal, which I showed you in the previous slide. And then comes the flange belt. Is like a concept which like an enclosure that goes on the top of the flange to protect the moisture intrusion at the flange faces. So these are the best practices we have come across. And another best practice from a tradesman standpoint. So let's pretend that we are insulation trade people. Yeah, cool guys, I would say. So what happened in the real life when they're applying the jacketing on the pipe? So because of the compressive force coming from this banding, so this leads to having the fish mouths in the jacketing because of the compressive nature, compressive forces being applied. So to address that sort of situation, so now the best practice is to use the hem edges. So all you need to do, basically, we just fold the edge of the jacket, at these portions, so those fish mouths can be avoided. So this is one of the way we can avoid that. So that's a best practice we have seen. Another best practice we have seen over here in the from the tradesman standpoint, like especially on the pipe shoes, generally if you look at some of the specification, they might say, hey, seal all the points, seal everything on the insulated systems. So yeah, seal those things, but there are certain portions that need to be kept unsealed. So here is an example of like a pipe shoe that was sealed, and after we opened that, the insulation was removed, we found the dense corrosion at those spots because the moisture was stagnant and could not drain out because of this caulking existing over there. Whereas in this case, you can see that the moisture is allowed to gush out and flush out freely. So this is one of the best practices. They don't seal at the low points alongside the pipe shoes. So this is another practice I want to share with you. So here are some closing thoughts. So we talked about the moisture gateways. That is actually the predecessor to CUI events. So that may come from the workmanship, process conditions such as thermal expansion and contraction. So our project specifications should be like that to accommodate, the effects of thermal expansion and contraction. and the interaction with the nature, which is we can't avoid that, unfortunately. So we have to think about like the innovative ways of how to have the system with more compressive strength. So that I'll cover that in the future webinar, how we can impart more compressive strength to the insulation system using some advanced type of systems, and also some eventful loading. Someone is stepping on that, field retrofits or maintenance activities that always keep the insulation, I would say, insulation reinstatement activities as the last punch items. So those activities cause the creation of the gateways, and also all these sort of things that I mentioned, those above said triggers can be avoided by the proper design, by the proper workmanship. And speaking about the CML ports, which may inevitably allow the moisture if they are not designed and maintained properly. So we need to maintain them properly, so that not to make a CML as a moisture gateway. So CML should be the data collection point, not a moisture gateway. And finally, I talked about some of the trademan thing that are being adopted in the industry. So that's all from my side, and thank you for being an active listener, in case you were listening. Thanks again.
All right. Thank you, Ahmad. If you have any questions for Ahmad, please put it in the chat. I'll give it another minute. Right. So the first question is from Elizabeth Hickson. Have you seen any systems which hold the insulation material away from the pipe, i.e. creating air gap?
Yes, exactly. So we have so that's another, like I would say, flagship product we do have with Integrity Products. We have developed different types of spacer systems, right? So contact-free design, like so spacer wraps, and also interestingly, Elizabeth, coming to your question. So not only we have developed the standoff system that keeps insulation of the pipe, but we have also the solution that keeps insulation of the jacketing. So we create a breathable gap between the insulation and the jacketing, which allows for in situ drying of insulation, of wet insulation. So these systems are very popular, and I would say they're adopted a lot in the industry at the moment. Yep.
Right. Thank you. And second question from Uwesh Bala. Are there any specific guidance for CML markup due to CUI to be adopted in RBI study?
Sorry, I could not get the question. Sorry.
So is there any specific guidance for CML markup due to CUI to be adopted in RBI study?
Oh yeah, I think that you're asking a lot. That's that's coming out of the experience with the facilities. I think it needs a lot of factors to be considered, like a historical data, some of the precedence guidelines. Yeah, there are some good guesses. We can do that. For example, the CML points, we can think about the elbows, low points, and various locations. But I would say perfect CML marking study could be done. It involves a lot of disciplines to be involved in that program. So yeah, I think it's a big question. But I would say there are some guidance that could be referred in API 571, I believe, that tells about where to inspect for CUI. Yeah, and also talking about the CML points. Generally, the purpose of CML points in general, what I understand, that is to look for the thickness loss coming from the internal corrosion or internal erosion damage mechanisms. For the CUI, generally there are a more advanced techniques, other than CMLs. So I hope I answered your question.
Right. Thanks for that. So next question is from Billy Morrison. You mentioned API 581 and the need for high confidence in result. Do you know how do UT readings compare to pulse eddy current regarding confidence? So less need to remove insulation.
Oh, that's great. Yeah. Oh, okay. Although I'm not an entity guy, but like obviously we have some, yes, pulse eddy currents. Obviously, it could be better understood, by removing the insulation and looking closely to that. I think, yeah, UT is still considered more reliable, based on what I have seen, because pulse eddy current is still, semi-quantitative, or at the qualitative level, it can tell you the defects, but obviously we need to strip off the insulation and really talk about the pit depth. So that's a bit tricky one, I would say. So I think it's more for an entity guy. Someone can give you better insights.
All right. Okay. Thank you. Right. That's all the questions. Last chance to ask. Ahmad, is you are expert here?
Ooh, okay, that's a big word.
Right. Okay. So that's all the questions for today. Thank you, Ahmad, for the very interesting presentations and the pictures as well.
Oh,
yeah, thanks for that. And I'm gonna end this session.
okay, sounds good. Okay. Awesome.
Right.
Yeah, thank you, everyone. Thank you for your time. I know it's late
Thanks
there.
everyone for attending.
Thank you.
Right. Thanks.
Bye.
Bye.